Now we're going to quickly go through this redox reactions and electrolysis quiz that you did on the Google Forms website. All right, so question number 1. Which of the following shows oxidation? So oxidation in terms of electrons is, remember, oil rig. So oxidation is loss. So we would expect to see an electron on the right-hand side of the equation, because that means that this thing here has lost an electron. You see here, Na plus plus E minus, I'm gaining an electron. That's no good. Okay, so we can immediately discount these two. They're not going to be the right answer. So then we just need to decide between these two. All right, well, if a positive ion loses an electron, it's not going to become neutral. All right. If a neutral ion loses an electron, it will become positive. So you have to imagine, remember, you've got this Na here. All right, it's in group 1, so it's got 1 electron in its outer shell. Now it's going to lose that electron, and it's going to become a positive ion plus the electron. All right, so you see this electron here, this cross, that's this thing here, that's the cross here, that's the electron. All right, so I've lost it, so this is neutral. And then when I lose the negative electron, I end up with my positive ion. Okay, right, next one. Which of the following shows reduction? So reduction now is, because it's oil rig, reduction is gain. So I would want to see the electron on the left-hand side being added on. All right, so I know immediately that's not going to be it because it's lost these 2 electrons. That's not going to be it because it's lost these 2 electrons. So technically, either of these could be reduction. Okay, and I think that confused a lot of people because they thought to themselves, well, if I'm gaining 2 electrons, I'm gaining electrons, therefore it's reduction. However, only one of these equations makes any sense. All right, and that's this equation here. All right, this one doesn't make any sense because if I have something that's negative, and I add on more negative electrons, I don't end up with something that's neutral. That doesn't make any sense. Okay, but up here, this does make sense, all right? So you have to remember that chlorine, the chlorine molecule is going to look like this. Okay, it is covalently bonded. All right, but if I break that up into the 2 atoms, you remember that I've only got 1, 2, 3, 4, 5, 6, 7 electrons on each one. Like this. All right, so in order for them to have a full outer shell, they need to gain the 2 electrons. So I gain in my extra electron. All right, I can use a different symbol. Let's use a triangle. All right, and because both of them have gained an electron, they're both going to be negative ions. All right, so yeah, if you chose this one, hard luck, but really, you know, it should be fairly clear that negative plus negative isn't going to give you neutral. All right, which of the following is not a redox reaction? So redox, remember, is where you have reduction and oxidation. All right, so I need to have both reduction and oxidation for this to be a redox reaction. All right. So here, what we do is we look at what the charges on the ions would be. So in iron oxide, if I've got Fe2O3, I know that oxygen must be O2 minus. And if oxygen is O2 minus and I've got 3 of them, that's 6 minuses altogether, but I've got 2 iron atoms, 2 iron ions, so they're both going to be 3 plus. All right, so this is really, if I split this up into its ions, it's Fe3 plus O2 minus. Okay, so I can do the same over here for Al2O3. Al2O3 is also Al3 plus and O2 minus. So if I have a look here, what's really happening? Well, I can split this up into 2 half equations because I've got Al is turning into Al3+. All right. How does it do that? It does that by losing 3 electrons. All right. And I've also got, well, I've got Fe2O3, but I know that the ion in my Fe2O3 is Fe3+, so it's Fe3+, and that's turning into Fe. How does it do that? Well, it has to gain 3 electrons. All right. So we've got loss of electrons up here, that's oxidation, and we've got gain of electrons here, that's reduction. All right. The exact same thing is happening here. Look, so my zinc is losing 2 electrons to become positive. My copper is gaining 2 electrons to become neutral. My copper ion is gaining 2 electrons to become neutral. So it can't be that one either. All right. Now, if we look very carefully at this one, all right, what we're going to do, we're going to break down all of these into their ions. So for this one here, we have AgNO3, all right, NaCl, AgCl, NaNO3. Now remember that the nitrate ion, NO3, is NO3 minus. So this must be Ag plus NO3 minus. Na group 1, Na plus, Cl group 7, Cl minus. So AgCl, remember again, Cl minus, so it must be Ag plus, and then Na group 1, and my nitrate is NO3 minus. So at no point have any electrons been transferred. All of the ions are the same charges. So even though they've moved around, the ions have moved around, I haven't changed any of the charges, so it's not a redox reaction. All right. Now this one here is interesting because this carbon atom gains oxygen to form CO. This carbon atom loses oxygen to form CO. So you can see I've got carbon adding an oxygen to make CO, and I've got carbon dioxide losing an oxygen to form CO. So it is a redox reaction. All right. Next, which of the following is false? When melted, ionic compounds can conduct electricity because they are free moving delocalized electrons. Yes, that one. Because delocalized electrons are what you get in metals. It's what you get in metals, not ionic compounds. Remember, ionic compounds are these things here, positive and negative ions. There's no delocalized electrons. The electrons have transferred from one atom to another atom to give you a positive ion and a negative ion. There's no delocalized electrons. All right, so whenever you think about delocalized electrons, that's in the metallic structure. All right, so the rest of these are all true. Which formula is incorrect? NaCl, Na group 1, Cl group 7, that's fine. MgOH2, Mg is in group 2, so it's Mg2 plus, and you've got OH minus, so you need 2 of those, that's fine. BaSO4, Ba is in group 2, and the SO4, the charge on that is a 2 minus, so that one. Na is in group 1, so it's Na plus. CO3, the carbonate ion has a charge of 2 minus. All right, see, these charges don't cancel out. In order for this to be a neutral compound, it's going to have to be Na2CO3. Which compound is incorrectly named? All right, well, for a start, remember that Cl is going to be Cl minus, NO3 is a minus, and SO4 is a 2 minus. Okay, so FeCl2. Well, if there's 2 chlorides, it means I must have an Fe2 plus, which is a 2, so that's fine. FeCl3, if I've got 3 Cl minuses, this must be an Fe3 plus, so that's a 3, so that's fine. FeNO3 3, well, NO3 minus, so if I've got 3 of these, that's 3 minuses, that's going to be Fe3 plus, so it's iron 3 nitrate, that's fine. FeSO4, well, SO4 is 2 minus. So if this is SO4 2 minus, this Fe here must be Fe2 plus, which would make it iron 2 sulfate. So that one is wrongly named. Okay. In the electrolysis of molten magnesium chloride, which of the following is true? So at this point, it might be helpful for us to draw out what the electrolysis of molten magnesium chloride looks like. All right. So we're going to have, this is the positive, this is the negative. We remember that the positive is the anode, because we know positive anode, negative is cathode. So this is the cathode. And we've got magnesium chloride, which is MgCl2. So in here, because it's molten magnesium chloride, I've only got MgCl2. It's MgCl2 liquid. I'm going to have Mg2 plus ions, and I'm going to have Cl minus ions. All right. Now the cations are attracted to the cathode, and the anions are attracted to the anode. So oxidation occurs at the cathode and reduction at the anode. Well, at the cathode, I'm going to have Mg2 plus is coming over here. So I'm going to have Mg2 plus 2E minus gives me Mg. And at the anode, I'm going to have Cl minus goes to form Cl2, so I need two of those, plus 2E minus. All right, so this is oxidation, because it's losing electrons. This is reduction, because it's gaining electrons. So we're having oxidation over here, reduction over here. Oxidation occurs at the cathode, reduction at the anode. No, that's not right. Magnesium ions gain one electron at the cathode. No, they don't. They gain 2 electrons at the cathode. Bromide ions are attracted to the anode. So for those of you that have managed to make it to this 12-minute mark, you'll realise that I've now realised that there's a mistake. All right, bromide ions attracted to the anode. No, that can't be true because there are no bromide ions. An orange-brown gas is formed at the cathode. No, that can't be true either. All right, because there are no bromide ions to form an orange-brown gas, so that's wrong as well. All right, so obviously the question should have been magnesium bromide, and if it was magnesium bromide, then that would be a Br minus ion, and it would be Br minus ions attracted there. All right, my apologies if you got stuck on that question. Moving on. Which of the following is not true for electrolysis? It can be used to obtain a pure sample of metal. Yes, that can happen. All right, so remember, up here, you're forming the metal. It's going to be a pure sample. It separates ions in an ionic compound by passing electric current through it. Yes, that's what I'm doing. Okay, you see the ions move in different directions because they're attracted to each electrode. It is always a redox process. Yes, I always get oxidation at the anode, reduction at the cathode. The separating ions produce a potential difference causing current to flow. No. Okay, the potential difference comes from the battery. The battery causes the ions to separate. The ions don't separate and cause electricity to flow. It's the fact that electricity is flowing that causes the ions to separate. And an electrolyte is a compound in the liquid state or solution which has mobile ions and conducts electricity. Which of the following is not an electrolyte? Lead chloride, metal, non-metal. That's ionic compound. That is an electrolyte. Table salt. Table salt is NaCl. Dissolve it in water, you have an electrolyte. Glucose. Glucose is C6H12O6. That's a molecule. It's a covalently bonded molecule. All right? There are no ions in there. Nothing to conduct electricity. And potassium hydroxide is going to be K plus OH minus. Which of the following shows oxidation is the gain of oxygen? Hopefully you can just spot that immediately there. Carbon plus oxygen gives you carbon dioxide. All right. Well done.